We are doing a question on practical electricity, November 2021, paper 22-4. The topic is practical electricity. A washing machine is working normally with both the water heater and the motor switched on. The washing machine is connected to the main supply by a cable. The current in the live wire in the cable is 13. State the size of the current in the neutral wire. The concept of neutral wire is there that neutral wire carries the same current. Neutral wire actually carries the same current but at zero potential. Neutral wire carries the same current but at a zero potential. So current comes from the live wire and this is the device and then it goes back through the neutral wire. So 13 ampere and 13 ampere. So it's virtually no energy in the neutral wire. The earth wire in the cable. Earth wire is actually like a safety, like an exit. Normally, exit line is empty. So normally, earth wire has no current. Earth wire is an empty circuit. So earth wire is considered to be an empty line. So when it is empty, it will be 0 ampere. The insulation on the main cable is now damaged. And as the washing machine vibrates, the live wire touches the metal casing. This is a dangerous hazard. How the earth wire and the fuse together prevent any more damage. What we have studied that if this is the washing machine, there is one wire which is live wire and there is a fuse in it. Then it is the neutral wire. Then we connect a thick wire like this and it is connected to the earth. So what happens that when you are facing any current leakage in the system, what will happen that suppose now current begins to leak in the washing machine. It is very dangerous. It can cause severe electric shock. So earth wire will begin to drain the current. Current will begin to drain. The current will begin to drain through the earth wire. Current will increase here. So at this point, the fuse will blow up. I have revised the theory and I have also made you people write the earthing concept. So what we should write here, it's a 3-mark question. So I have given you people the concept. So what you can, now you can answer me. You people have to make an answer for me. Explain how the earth wire and the fuse together prevent any more damage. So please quickly, you can answer on the mic. You can answer on the Zoom chat also. I have a 3-mark question. So please, I have told you the theory again. Um, okay, you if you have written it, ideally you can write it here or tell me on the mic. So otherwise, you can write it because they sending me. If you want to send me a picture, then it's also fine. But uh, what about Asad? What do you think? Can you make an answer quickly? That's a good answer. So both answers are right. So I'm sharing Asad answer because he has given the answer first, but both answers are right. So even Maha has given also a very good answer. So these answers are perfectly fine. So we can take one answer and the point have been transferred. The concept has been transferred. That actually, what is the main idea? That the fuse will actually blow. Fuse will blow because why the fuse will blow? Because the current will be excess. Explain why it is the live wire into which the fuse is connected. The answer is always simple that fuse is always connected in the live wire because live wire carries the high energy electrons. Protection is needed there. So live wire has the higher potential. Live wire has always the higher potential. So we need protection there. So answer would be that live wire has higher potential. Live wire has higher potential. So protection is needed there. November 2021, 22/5. Note down the year number. Now read this question. The figure 5.1 shows a circuit that contains a direct current DC power supply, a light dependent resistor, two fixed resistor M and N. First, you people should try that if you get this question in your book. So maybe it is in that book, but in a different position. November 2021, 22/5. The reading on ammeter 1 is 1.6 ampere. Calculate the time taken for a charge of 7.2 coulomb to pass through ammeter 1. So what's the formula? I is equal to Q upon T. So T is equal to Q upon I. The the charge is 7.2 and the current is 1.6 milliampere. So I will convert it into normal ampere. Okay. Asad is saying answer is 4.5. It's 4,500. Okay. Sometime later, the brightness of the light incident on the LDR decreases. What was the behavior of LDR? LDR is a semiconductor. It's a semiconductor. What are the properties of LDR? As brightness increases, resistance of LDR decreases. As brightness increases, resistance of LDR decreases. Opposite. So the brightness of the light incident on LDR decreases. So when it decreases, the resistance of LDR will increase. The reading on ammeter 2. So what you people will suggest that resistance of LDR is increasing. When resistance increases, current will increase or decrease. Resistance is increasing. Current will decrease. Ammeter 2 is talking about ammeter 2, not ammeter 1. So current will decrease through the LDR. That is right. But what about ammeter 2? LDR resistance will increase. Current will decrease. But what about current here? The time taken for a charge of 7.2 coulomb to pass through ammeter 1. What would be the answer for B part 2? So need suggestion for this part. He says that the time taken for a charge of 7.2 coulomb, current has increased. So when current increases, the denominator will increase. Current and time are inversely proportional. If you look here, current has increased, so time will decrease because current and time are inversely proportional.